Hello children, this is the fourth part of the chapter motion. In this video, we are going to learn about the uniform and non-uniform motion. What is uniform motion? When an object covers equal distances in equal interval of time along a straight line, then that kind of motion is said to be uniform motion. It is defined as an object is said to have uniform motion if it covers equal distances in equal intervals of time along a straight line. Then what is non-uniform motion? An object is said to have non-uniform motion if it covers unequal distances in equal intervals of time. We'll understand this better with the help of an example. Suppose a car is traveling when it covers zero kilometer in 0 hours. Okay, now after 1 hour the distance covered by the car is 20 kilometers. After 2 hours the distance covered is 40. After 3 hours it is 60, and after 4 hours it is 80. Now what is the time interval? This is 1 hour. From 1 to 2 is 1 hour, 2 to 3 1 hour, 3 to 4 is 1 hour. And what is the distance covered in 1 hour? It is 0 to 20 kilometers, 20 to 40 20 kilometers, 40 to 60 20 kilometers, and 60 to 80 20 kilometers. Here you see that every hour the car is traveling 20 kilometers. That means it is covering equal distances in equal time intervals. That is why this motion is said to be uniform motion. We can say that the car is in uniform motion. If we plot a graph for that, the distance time graph for uniform motion will always come in a straight line. Further about this uniform and non-uniform motion in detail you are going to study in higher classes. Non-uniform motion. An object is said to have a non-uniform motion if it covers unequal distances in unequal intervals of time. 0 kilometer the car is covering in 0 hours. It covers 20 kilometers in 1 hour, 30 kilometers in 2 hours, 60 kilometers in 3 hours, and 80 kilometers in 4 hours. What is the time interval? The time interval is 1 hour. Okay. And what is the distance traveled in 1 hour? From 0 to 20 kilometers. From 20 to 30, 10 kilometers. From 30 to 60, 30 kilometers. And 60 to 80, 20 kilometers. So, we see that here the car is traveling unequal distances in equal interval of time. First hour 20 kilometer, and then in the next 1 hour it is covering 10 kilometers. This is unequal distances in equal intervals of time. Then when we plot a non-uniform motion graph, the distance time graph for non-uniform motion never comes to be a straight line. It is always in the form of a curve. Clear? Now coming to physical quantities. What are physical quantities? Physical quantities are those quantities that can be measured. And we express physical quantities in two things, that is magnitude and unit. Suppose you go to the market, okay, to buy anything, any vegetable. Then what do you say? Do you say give me 2 potatoes? Suppose you are buying potatoes. Do you say give me 2 potatoes? No, you ask for a kg or 2 kg or half a kg. Okay, here if you are asking for 1 kg of potatoes, here this 1 is what? The magnitude, and this kg is the unit. So a physical quantity always has a magnitude and it has a unit in which it is expressed. Physical quantities are of two types: scalar quantity and vector quantity. Then what is scalar quantity? A physical quantity that can be described only by its magnitude, that is the numerical value, is called a scalar quantity. Okay. If I say 1 kg, then that is an example of scalar quantity, because here when I am saying 1 kg, I am only talking about the numerical value. Examples of scalar quantities are distance, time, mass, speed, temperature, area, volume, density, work, energy, etc. All these are the examples of scalar quantity. Scalar quantity is what? It is a physical quantity that can be described only by its magnitude. Magnitude is what? The numerical value. Okay, so if I say 1 kg, then this 1 kg I am only talking about the numerical value. So this 1 kg is a scalar quantity. Now what is vector quantity? When a physical quantity needs both magnitude and direction to be described, it is called a vector quantity. Suppose I say that I am walking for 2 kilometers towards north. If I say I am walking 2 kilometers towards north, means here I have given both magnitude and I am giving the direction also. So when a physical quantity needs both magnitude and direction, it is said to be a vector quantity. Example is displacement, velocity, acceleration, force, weight. Now I think scalar and vector quantity is clear now. Scalar quantity only magnitude, vector quantity magnitude with a direction. Okay, 2 kilometer is magnitude towards north. North is the direction. When we add direction to the magnitude, then it is a vector quantity.